All right, CNT120, Chapter 1. Let's do this touch on the section here on backbones, or backbone networks. Our backbones are really the connections between our main networking devices, usually switches, sometimes routers. This is also the connection between our closets. I have little air quotes there. Typically, the connection between closets in my network and between my buildings is usually a high bandwidth backbone link. So my backbone networks, my backbone connections are usually these between my large networking devices or between my closets, if you will. These backbone links are typically large throughput. So if my desktops are getting 100 meg, the backbone connection needs to be at least gig. If the desktops are getting a gig, then the backbone connections need to be 10 gig. And the idea there is, think of all the roads, all smaller roads merging onto a highway. The smaller modes might be 2 lanes and, 40 mile an hour limit. Well, when all these smaller roads dump onto the highway needs to be more lanes and a, maybe 55 or 65 mile an hour to handle all that extra volume of vehicles merging onto the highway. Same kind of idea here. These backbone links can be copper, but oftentimes they're going to be fiber for distance needs. Between my closets sometimes can be great distances. I might need to go a couple hundred meters from the closet in one building on my network to the closet in a different building on my network, maybe across the parking lot, if you will, or across the campus, if you're thinking of a college campus, between those buildings. I might need to go a couple hundred meters, and fiber optic will typically be used for that. So there are a couple different types of backbones. There is a serial or daisy chain backbone. This is the one they mention in the book here for a daisy chain. This is a simple backbone. I'm literally connecting 2 or more devices and I'm kind of linking them along. A lot of modern networks don't use this, as we'll see in a minute why, but it is a way to connect together multiple closets or multiple networking devices. I literally just go link to link to link. And here's a different drawing I did. Think of this as maybe a multi-floor building. If I have a multi-floor building, I can literally just go switch to switch to switch, and then, my router firewall out to the internet, if you will. This works. There's nothing wrong with it, if you will. It works. The downside when you start looking at it is all of this traffic up here has to go through here, and then all of this traffic has to go through here, and then all of this traffic has to go through here. So these start creating log jams, if you will. They start creating log jams, and or they create problems if, this link here breaks, this whole floor is done. If this link breaks, both floors are done. If this link breaks, all 3 floors are done. So there is some problems with it. The advantages, though, are it is low cost. It's really simple. I don't need many device ports to do it. The downside, though, is, as we just said, the bottlenecks as well as the failures. If one of those links break, I could be affecting two or 3 floors of devices. Another type of backbone is a distributed backbone. With a distributed backbone, I now, instead of just connecting my switches directly together, I add maybe a router device. A router device has more intelligence, so it's able to do more processing. It's also able to do a little bit more security too. So I'm going to use my 3-floor example again. I might put, instead of just connecting my switches directly together, I might put a router on each floor and then connect them. Well, what that's able to do is it's able to add a little bit more intelligence and a little bit more security to this building. So maybe I need to keep the data on these floors separate. Maybe there is, financial data up here. Maybe there's health record data here, and maybe there's, other financial data down here or employee data down here, and I need to keep these floors separate. Well, by putting a router on each floor, I can have some security there of like, well, this traffic does not mingle with this one, this traffic does not mingle with this one. So by doing that, I'm actually taking the backbone and kind of breaking across all floors, and I now can add in a redundant link potentially on my device here, so that if this link here breaks, this router can still pass it down this way and out. If this link breaks, well, I can literally route traffic the long way around and still get out. So it has a little bit of advantage to it with adding some of that traffic control security as well as maybe a redundant path to it. And that's what we said right here. I have security backbone, etc. But I still do have potential for single points of failure in this network. And the adding of these routers not only adds financial costs because I need to buy them, but it's also going to add latency. Latency is the processing time. Each one of these routers does take a little fraction of time to process and move the data. So by adding these in, I've added extra processing time for this data to move from the floor out to the ISP, out to, wherever it's trying to go outside of this network. Collapsed backbone. A lot of companies use a collapsed backbone. This is kind of the middle of the road. It kind of takes pieces from both, if you will. Here's one example here. Here's another example using my 3-floor example. What happens now is, instead of going switch to switch to switch or adding routers on each, I have all these switches connecting to one device here. In this case, it's a layer 3 switch. A layer 3 switch, real quickly, takes a switch, but adds a little bit of intelligence to it. The switch is layer 2, a router is layer 3. It takes a switch and adds some routing capability to it. So you're kind of getting the best of both worlds. The switch moves data through quickly, but I add the layer 3 functionality on top to give it some smarts. So I have a little bit of smarts to this, but I also keep data moving quickly. And this layer 3 switch, I can have a lot of ports on, so I can literally have an individual connection from each of these floors to this device. So again, I'm trying to take the best of both worlds here, and I have an individual connection to each of these. So if I have a failure here, it only affects that floor. If a failure here, it only affects that floor. And I'm moving my data through quickly. So I'm literally trying to combine kind of the best of both worlds here, best of the daisy chain as well as the best of the distributed with my collapsed backbone. That's why a lot of networks use this kind of model. I can connect my different networks. I have central management. If I have that layer 3 device, I can route the data through, but at the speed of a switch. So I'm trying to do the best of both worlds. I still do have central point of failures, and all the data does need to move through that bottleneck. So there is still limitations. It's not perfect. The last model will be a parallel backbone, and this is usually when the need arises. And I'll go back to the example of a hospital. A lot of times in a hospital, this network needs to work 24/7, 365, even on holidays. Even on weekends, even on holidays, it needs to work all the time. So it might justify the need for redundant links from each floor to redundant links down here and out to the ISP. Now, I did a lot of redundant links here. Some of these could be dealt, you could cross some of these off or get rid of some of these. But the idea is I have a redundant link from every floor here and out to the ISP. That's what your parallel backbone is. When the need arises, you add these redundant links in for reliability, fault tolerance. An example of a hospital, this would be necessary. This would be necessary to be thinking redundant links to each of my major network devices. That's your parallel backbone. Here, redundant links, increased performance, better fault tolerance. It is going to be a lot more costly because of devices. It's going to be a lot more costly because of ISP connections and that sort of thing. And I do need extra ports on my devices to make this occur. I'm consuming more ports to make this happen. But there are some of my backbone. There are some of my backbone technologies.